All right, now you all are experts in naming ionic compounds, polyatomic ionic compounds, and acids, and we're going to do our last thing we're learning how to name, which are molecular compounds. So what's a molecular compound? Well, an ionic compound is a bonding between metal and a nonmetal. Molecular compound is bonding between two nonmetals this time. So we're going to be working in like the upper right-hand corner of our periodic table. Um, Remember with ionic compounds, they were trying to be like noble gases, remember? And they were going to like give away and take electrons to be like a noble gas. And remember for the nonmetals, they were always trying to gain extra electrons to be like a noble gas. And so all nonmetals always have a negative charge. And so if we're talking about nonmetals bonding, if we've got two nonmetals with two negative charges, would those things ever cancel out? Would those opposites ever attract? No, because they would never be opposite. They'd both be negative. We could never get those charges to balance. So because of that, nonmetals, they do a slightly different thing. They end up sharing their electrons to become more like noble gases. And we're going to get into this more later on in the year, exactly what that looks like and how it works. But they're going to do a slightly different thing. Okay, so for this portion on, we're not going to worry about charges. So I know we've been really hitting the charges hard, but now you got to kind of disconnect and put charges on hold because they're not going to do a charge thing because it's never going to work for two negative things if they form charges. Okay, so just kind of set that aside in your brain for a minute here. So with our molecular compounds, we are going to name the numbers. So remember, like if we had a little number in there, we never ever said that number in the name. It was just like potassium sulfide, even though K2S, like we never said the 2 with the potassium. Well, here we are going to actually name the numbers, okay? So this little 2 in here, because here we have a nonmetal, this little 2 is going to actually get included in the name, okay? And here's how we do this. These are 10 prefixes that you need to know. You just need to memorize them. You're not going to be given to them. They're not on like a reference sheet. You need to know them, okay? So pause this, write down these 10 because you absolutely positively have to know them, okay? Some of them you might be familiar with, other ones you might not have heard of before, okay? So pause and then play again when you're ready to move on. All right, so here we go. Let's try an example. P2S3, again, two nonmetals, so I know it's molecular. So there's two P's, so if I look over here, that's di, and then three S's, so that's tri. So the name would be diphosphorus trisulfide. Okay, so notice again, the first thing's name stays the same, the second thing's name ends in IDE, but we do include these numbers in the name, diphosphorus trisulfide. Okay, how about this one? H2O, we call that water. Well, what's the chemical name for water? Well, there's two H's, okay? So that'd be dihydrogen and one oxygen, so that's mono. So this would be called dihydrogen monoxide. Oof, that sounds pretty scary, huh? Actually, for a while, there was this kind of fake online petition with this website set up that was all about the dangers of dihydrogen monoxide, and it's in everyone's drinking supply, and it's in your body right now, and click here to sign a petition to get your government to take dihydrogen monoxide out of the water. And like hundreds of thousands of people signed this thing. And then the whole point was it was like, well, it's just water. Like people sometimes get so freaked out over these names and they don't even know what they're talking about. And if you want to, just like Google dihydrogen monoxide and you'll find some of these websites and they're hysterical. Anyway, so don't be caught up in the hysteria. It's just water. That's the chemical name for water. Here's another example, CO. So that would be one carbon, so mono, and one oxygen, so that'd be also mono. So monocarbon monoxide. Well, that would be too simple, wouldn't it? And I don't know why they made this rule, but when the first thing is one, we don't say the mono. So it's carbon monoxide. And I'm sure you've all heard of carbon monoxide. You have detectors in your houses for them, okay? So why don't we say monocarbon monoxide? I don't know. But with the first thing, we never say mono if it's one. Okay, so that's like our one exception to the rule, because there's always got to be an exception to the rule, right? Thankfully for this, formula writing is super simple because we're not worrying about our charges, and the names will tell us the numbers because of the prefixes. So if I've got dichloride heptoxide, di is 2 and hept is 7, so it's Cl2O7. Great. Phosphorus pentachloride, No prefix means it must be 1. Penta is 5, so 1 phosphorus and 5 chlorines, PCl5. That's it. So naming molecular compounds and formula writing are pretty easy, pretty straightforward. As you can see, we're not using charges. The only thing that you have to really worry about is learning those 10 prefixes. All right. We'll be doing more with this in class as practice, but now you officially learned how to name all the things that we'll be naming in chemistry.